from Hood and National Institute from the Department of Civil Engineering. I'm going to start this course named Structural Design Engineers, and that is basically for the basic structural design of steel structures. So we'll discuss this in detail in coming slides, what is all about the structural design and the engineering part of it, specifically for the steel structures. And going further, that is a very basic part. Going further, so then we have to discuss about what is the prerequisite before starting this particular course. You should have learned about the mechanics of material and structural analysis 1 and structural analysis 2, which is the advanced part of the structural analysis, which is required before starting this course. And the third one is the building material. If you talk about the building material in terms of the structural design, the most commonly used building materials are the concrete and steels. So in this particular part, you should know about the basic idea about the properties of different kind of material which is used for the constructions. In the mechanics of material, you should learn about the statics and dynamics and the macro parts of material properties. And in the structural analysis, you should be learning about the structural analysis, how the structure will behave after applying the different kind of loads on it, so that we can give a foolproof design. Then coming to the next slides. In the beginning, let's discuss about what is structure is and what is architect is all about. It says what is structure basically. A structure should be, if a structural design, if you're designing any structure, a structure should be exemplified. It means a structure must be safe, useful and beautiful. It was the definition which is as per the definition given by the Marcus in 31 BC. So it defines as simple as a structure should be exemplified, and it is a safe, useful and a beautiful structure. It must be a safe, useful and beautiful structure. Going further, let's discuss about the basics of design, the definition of design. What is design basically? It is nothing but a mixture of art and science. The combining the both the experienced engineers intuitive feeling for the behavior of structure with a sound knowledge of principle of statics, dynamics, mechanics of material and structural analysis to produce a safe, economical structure which will serve its intended purposes, which you have already seen in our prerequisites. So if you talk about the design, the definition of design, it says you should be knowing about the principle of statics and dynamics and mechanics of material and structural analysis. If you know about these subjects, if you learn properly about these subjects, then after that you will be able to design a structure. So in this particular course, we are going to discuss about it, how to properly design and give a functional design of any structure, how to plan, what is the role of different members which are included for the design purposes, and it is basically the what you have to design. So in at the last, you can give your customer a very safe, economical and structure which serves its purpose, which is basically designed for. Just a take example, if you're designing any hospital structure, so that particular structure which is designed which saves its intended purpose. Okay, so that is the basic definition of design. So a designer should know these requisites, which is the principle of statics, dynamics and mechanics of material and the structural analysis, both. Structural analysis 1, which is the primarily structural analysis, and the second is the advanced structural analysis. If you have knowledge about the good and sound knowledge about this particular topics and the subjects, so you will be able to design any structures. But further, we have a design. Why art? It says, as per the design in the previous slide, it says that design is nothing but the combination of art and science. If you talk about the art part is the nothing but the imaginations of that particular engineer or the designer and the creative ability and his experience and the judgment he will take at the time of design, so that he can give a aesthetic quality. Aesthetic quality means what? He can make a beautiful structure. So this person, the designer, must have a good imagination, his creative ability, which affects that particular design part, okay, how aesthetic structure would be, and what is the experience he is having. If you have a good experience and the vast experience about the design of structures, so he can give the very proper and detailed kind of design and his judgment at the time of designing. So in the photograph, in the slide which is given the photograph, you can see the bridges, and we can compare it with the number of bridges which we are having in our country, which is old enough. So the aestheticity can be compared. So this bridge which is in that particular slide is more beautiful as compared to the other bridges which we see, the old age bridges. So it gives you what? It gives the imagination. The designer, when he set for the designing, he should have the imagination about that particular bridge, and then after that he has applied his creativity, ability and experiences, and then after that he judges. Judges means what his judgment, which gives the total aesthetic view of that particular bridge. Going further, that is the art part of your design. The second part is the science, which is a very important part. To make a structure, any structure design, to make it safe and economical, which is most important part. For any engineer, any design engineer, the foremost priority of any design engineer is the safety part. You should not be compromising on the part of safety. The second is the economy, because there is always been a limit to the resources and the money. So the safety and economy is the most important part of any design part. So you should not be compromising on the both part, but the foremost is the first comes as the safety and the second is the economy. So though both safety and economy go in hand, and the safety will give you nothing but the behavior of the structures, how the structure will behave for the different load conditions and the important environmental impact on the particular material. And the second part is the functional and environmental qualities. Functional and environmental qualities which gives the proper design part. So that is the basic behind the science applied in the designing that particular structure for ensuring its safety and the economy. Going further, we have the design. If you go through this particular slide, which is giving the bridge, which is clearly you can see that is a proper mirror of that particular bridge in that river, and that's give you the very aesthetic part of that particular bridge. But it is also having the science part, the safety and the economy part, which the designer or the contractor or the constructor have built that particular structure. So it should having in the mind the safety of the structure, because the people are crossing that particular bridge. It should not collapse. The safety should be kept in mind at the time of design, and the economy itself. And after all, after combining the both components of the design, the art and science, then we have a structure which is we can see clearly it's a very beautiful structure, and it is safe and economical as per the thought process of the particular designer. Going further, we have the two parts, the basic parts before giving the foolproof design or the functional design, we can say. So there are two parts, which is called the analysis and design. Now these two are the components of designing or the giving the functional design. So analysis is a different part and then design is a different part. So this is a debate between the engineers, basically design engineers, which comes first, what you have to do first, the analysis or the design part. So the answer should be given, that is a very funny kind of thing, which comes first, the hen or the egg. So let's discuss about it, and we will are able to understand which comes first, what we have to do first. We have to design first, or we have to analyze first any structure. So let's go ahead and discuss about it. Now we can see the analysis and design part, which comes first. So you can see that this is which we are having the two kind of structure, the beam, which is having UDL per unit length of a particular structure. So you can see clearly if you apply the load. Now see this one, if you have the beam, now it is having some dimension, it is having some material properties. Now deciding the dimensions of the particular beam and the material properties is called the design. Then after that, applying the load, the required load on the particular structure, and giving the deformation of the particular structural bend moment diagram and shear force diagram. So it gives you what? It gives you the safety of the structure. It ensures that this structure is functional or not after applying that particular kind of load on this particular structure. If you see the structure is not failing, it means your designing is okay. Designing means what? The material properties and the dimension of the particular material. Now, moving further, it means it is very clear. We have to design first. We have to choose the material and the dimensions of the particular structure member, so that we can apply the load on the particular structure and analyze and see if the structure is safe or not. If it is not safe, then we have to go again for deciding the particular dimension of the structure and the material properties. If then we have that is an iteration process. This is go again and again until the structure is safe, and then if the structure is safe, then we have to apply the economical part to change some dimension to save some money on the particular designing of the structural construction part. Going further, we have seen already the analysis and designing part, which comes first. Now, the which comes first, the design and requirement and design processes. There are two things. The first, the design requirement, and the second is the design processes. So let's discuss about one by one, which is what is the design processes and design requirements. So let's go discuss about it. What is the designing processes? If you talk about the design requirements, so we have to build for the needs. So design requirements are basically there are two things: to protect and to movement. But what is important of these 2 points is to protect when the people are living inside any houses. So what is they have to do? They have to protect themselves from the external environmental condition, harsh environmental condition. And second is to commute from one point to another point. So this basic purpose of design is to protect that persons, protect the people from the environmental conditions, and the second is to move from one point to another point. Let's discuss further what is design requirement to build for the other needs. There are some other requirements for the other needs, like if you just not just from the protection and the movement perspective, there are some other kind of design also. Just like example of you can see in the photographs, we have a mobile tower, which can also be designed, or there are some electricity towers which is also be designed. That is basically the structure, but for the transmission of electricity from one point to another point. So there are the other requirements for the designing. Now the next one is the design requirement. What are the issues? We have to check it out. What is the design requirements? So there are the example which is given here. That is the first is called the functional requirements. So there are the three kinds of pen we have. The first one is writing accessories we have. The first one is nib pen, second is a ball pen, third is a pencil. So the requirement of three resources which we have right now is a ball pen, nib pen, and your pencils. The all three components is having different work altogether, because what you have to do with that particular pencil, you can't do it with the ball and nib pen. So these are the issues which we have to discuss, which we have to clear before the designing part. This is the planning phase. So we have to check what is the functional requirement of the particular structure, particular design part, what is the requirement of the particular client. So then after that we have to go for it. Now next part is our issues involved in that particular field, the feasibility. Feasibility analysis is there. You can see that the Alaska Transline pipeline, this is the feasibility analysis. We have to put that particular pipeline in the straight mode. That should be a great idea. And go for the constructability. Then we have to check it out. Okay, is it possible to construct that particular section in the particular place? So that what is the basic requirement of the constructability? The first is the locally available material, and second one is your construction workers. That is the most important part to discuss about it. We have to think at the time of designing, is it constructability is feasible or not at the time of construction. So there should not be any hindrance at the time of construction, so that the project can be completed at the required time period. The next one is the safety, which is very important part. The safety is for the three peoples basically. The first one is the constructor at the time of construction. So the constructor and the labor should be kept safe, and the second one the users. So after the construction, then the occupant we have to be saved, and the user should be safe. So the safety requirement is very important. The third one is the environmental part. So when both are done, then we have to check it out how the structures are affecting that particular environment. Then we have to choose the material accordingly. The kind of material which is environmental most nowadays, the people are using most environment friendly material to to protect that particular environmental, to protection of carbon footprint, reduce the carbon footprint of the particular structure. So going further, then we have to check it out the service life of the particular structure. That is the issues which we are discussing right now. The service life of the particular structure. Take an example of that aircraft and the pens. Then each and every material is having their service life. So the service life is kept in mind at the time of design requirements, and the durability of the material, which I have told in the prerequisites. Then you have to learn about the building materials and the properties of the different kind of materials. If you take an example of this particular pillar, which is not corroded yet. Why? Because the property of material is such so that the durability is decided, because we kept in mind at the time of design what will be the service life of the particular structure. Going further, the economy part. Now take example of the economy part. So this is a bridge. This is the most expensive kind of construction work which we have dealt with. So there is a limit of any resources and the money. So we have to be very careful about our economy part also. So this is a economy which we have to kept in mind at the time of design. So that the particular given you can say money or the resources, we have to complete that particular design part. The aestheticity, which is most important part, which we have discussed already. This is science and art. So aestheticity and the beautifulness of any structure should be maintained. And the next one is accidental overload, which should not be. We should keep in the mind in future if a structure will have a different kind of loads, the accidental load or the overloading of the particular structure, or any fire or the earthquake or natural calamity will hit that structure. The structure should be safe and can be evacuated easily. So that should also be kept in mind before the designing part. And after that, this issues we clear that particular issues which is in the design part. Then we have to provide the foolproof design of the particular structure. That is the design requirement which we have right now. Okay, so this is the basics of our design part and the definition which I have given. And the issues requirement, issues involved in the particular part. Going further, so if you have any query about the particular codes and the particular slides, the previous slides which we have discussed in the very basics of the design requirements and the design definitions of design, a structural engineer, and then you can mail me on that particular mail ID, which is mayank.write@nai.edu.in. This is it for today's class. We'll discuss different project planning and the role of structural engineering in the next classes. Till now, thank you so much. Bye bye.